where you are, where you're from, and where you're headed to. Thanks to physics, you have tools that can help you to identify your exact position. And here, I am in St. Anthony, and today we're going to talk about those two tools, the distance and the displacement.
Let's start with distance. Distance is a measure of how far something's traveled. The SI unit for distance is meters. Distance is a scalar quantity. It's only the magnitude of how far we've traveled. The direction we moved in doesn't matter. So let's say Mark is standing on a number line. He's starting from 0, which we'll call his origin or his starting point. If he moves 2 meters from the right, the distance he's traveled is 2 meters. Now, let's say he moves 4 meters to the left. His total distance from his origin is 2 meters plus 4 meters, which equals a total distance of 6 meters. With distance, the direction you travel doesn't matter. So even though he went 4 meters in the opposite direction, the distance will always be a positive number. Now, what if he walks 3 meters to the right? The total distance he's traveled is 9 meters. Again, when measuring distance, the path he takes between an origin and destination matters. So even though he ended up only 1 meter away from his origin, his total distance traveled is still 9 meters. But what if Mark didn't want to know the path he took throughout his journey, and only cared about the difference in meters between his starting point and ending point? That's where displacement comes in. Displacement is an object's overall change in position. Just like distance, the SI unit for displacement is also expressed in meters. Displacement is a vector quantity, which means it has a magnitude and a direction. So let's go back to our number line. If Mark moves 2 meters this way, the distance he moves is 2 meters, just like before. But his displacement is 2 meters to the right. Now, if he moves 4 meters in the opposite direction, the total distance he traveled since starting is 6 meters. So if he moves 3 meters to the right, again, his distance adds up to 9 meters. But his displacement for the whole journey is 1 meter to the right. So why is that? We know our displacement is the difference in meters between our initial position and our final position. That means the route we took to get there doesn't matter. The only thing that matters is how far we are from the origin and in what direction we ended up. Distance was 9 meters, but his displacement was 1 meter to the right.